Hi students, and welcome to another week of distance learning. This week we are going to continue our exploration of Entity Framework Core 5.0. In the center of our attention this week are relations between classes and inheritance. We are going to create a data model containing inheritance, relations one-to-one, one-to-many, and many-to-many. And we are going to take a look at how we can add data to such a model and how we can query data from such a model, including relationships. And just like last week, I encourage you to follow along. So whenever you want, pause the video, take a look at my code. Maybe you have to rewatch 1 or 2 minutes, and then fire up your own Visual Studio and recap what I did. Try it on your own. It's not enough that you just watch the video. You have to try it on your own, because then you really understand what's going on. During the lesson, when we have our lesson on Thursday, I will be online on Discord and Teams. So if you have any problems understanding the material that I show you, or if you have problems repeating the sample code or coding the sample code, or if you have some syntax problems, or if your code crashes, just don't hesitate and come to Discord or Teams so we can take a look at your code together, or I can describe the concepts again to make really sure that you understand the basic principles of relations in entity framework models. With that, without further ado, let's jump right into the topic. This picture shows a class diagram in Visual Studio of the model that we are going to build together. Imagine that you build a shop for used Lego bricks, okay? If we build a shop for used Lego bricks, we could store these bricks in a brick table. Every brick, every Lego brick has an ID, a title, and a color. We can have multiple base types of Lego bricks. And of course, that can be modeled using inheritance. So we, just as an example, have a class which represents base plates, larger plates. Base plates have a length and a width in addition to the properties that they inherit from the brick table, from the brick class, sorry. Additionally, we have a class which represents a minifigure head, and this minifigure head has a property which says is dual-sided and represents the fact that the minifigure has 2 faces printed on opposite sides, whether or not it's a Boolean property. Every brick has 0 or many tags, and every tag can be assigned to 0 or many bricks. So this is a typical many-to-many relationship between 2 classes. Every brick can be bought by a vendor, you see it, or by multiple vendors to be more exact. The relationship between brick and vendor is explicitly modeled by using a separate class which I called brick availability. This class represents the relationship between brick and vendor, meaning the availability of this brick to be bought by this vendor. And it has additional properties, namely the available amount that the vendor is able to ship and the price in euro. So this is our data model. Of course, related to the data model is the data context. This is the data context where we can access the bricks, the tags, the vendors, and the availabilities. We also have a brick context factory. This one, we already talked about it. We can use it to create our database context, and the brick context factory reads our connection string from appsettings.json. If you followed the video last week and the week before, you should be pretty familiar by now with data contexts and data context factories. By the way, did you know that Visual Studio is able to display such nice data models? Yes, it's pretty simple to create a data model like that from ready-made classes. I can quickly show you because maybe it's interesting to you if you have an existing project and you would like to document your data model using a data model class diagram in Visual Studio. All you have to do is you have to click on Add New Item, then you look for a diagram. Here it is. Here we have a class diagram. Let's add, just for demo purposes, another diagram. And then you can go to class view. Here you see the class view. You select all the different classes that you would like to display and drag and drop it up here. Then you can open it up just as you want. If you want to display the details, just fold fold or unfold the details so you can see it. And the relationships can easily be added to the diagram. For instance, here we have at the brick availability here, we have a relationship to a brick. We can just right click on that, show it as an association, and that will display a nice arrow associating brick availability with one brick. On the other hand, this is a collection. A brick can have multiple availabilities. You can say show as collection association, and then you will see that you have this nice collection association. So if you're working on your multi-year project or on your diploma thesis and you need some nice class diagrams for your solution, you can easily use this class diagram feature from Visual Studio, and at the end you can also export this diagram as a PNG file and add this PNG file to your project documentation. So this has nothing to do with Entity Framework. It's just a feature of Visual Studio, but I thought it would be interesting for you to know and understand that Visual Studio is capable of generating such diagrams and maintaining such diagrams for you. I hope that was an interesting detour, but with that, we go back to our Entity Framework lesson. Let's start coding. Let me get rid of this instance of Visual Studio and fire up a new version of Visual Studio. And here, I encourage you to do the same. Please start Visual Studio, and we are going to start with a brand new project. Here, it's a console app in .NET Core, so please put it somewhere where you would like to store it. I will call it Entity Framework Relations. This is what I would like to create. Press create, wait a few more moments, and then you should have your Visual Studio solution just right here in front of you. As always, we are going to switch from .NET Core 3.1 to .NET 5.0 because we would like to use the latest and greatest features of .NET 5, and we are also going into the Lang version preview in order to use the latest and greatest preview versions of C# because we really want to be leading edge here. Good. And we also know that we can remove all this unnecessary code because in Visual Studio, in .NET 5 and C# 9, we don't need a main method. It just works. Good. Let me check on my list of things that I would like to show you what else we want to do. Okay, this time we start from scratch. Last time I used an existing project, but this time I would like to quickly recap the steps that you need to do in order to get Entity Framework up and running. And one of the first things that I would like to emphasize again are the NuGet packages that you need to add in order to make your project work with Entity Framework. Just right-click on the project, go to Manage NuGet Packages, and quickly think about, can you remember which NuGet packages you need for Entity Framework? Well, it's pretty simple. You just look for Entity Framework and then look around what you can see. They all start with, to be more specific, Microsoft.Entity Framework. And then we had two very important NuGet packages that you can add, or you have to add, in order to work with Entity Framework in the way we do here in this course. The first one is Microsoft Entity Framework Core Design. So remember that. Add NuGet packages, and the first one you need to add is Microsoft Entity Framework Core Design. Use the latest version, 5.0, in order to get the latest version of Entity Framework and install it. It will only take a few moments, and you have all the design capabilities of Entity Framework added to your application. The second NuGet package that you have to add depends on the kind of database you would like to use. You could use SQLite. you could use, if we scroll down a little more, things like, where is it? Ah, there are some additional relational databases down here, but the thing that we are really interested in is this one, Microsoft Entity Framework Core SQL Server. So this is the second one that you have to install in order to access SQL Server, in our case, SQL Server LocalDB. If you can't run LocalDB, no problem. Run SQL Server in a Docker container. You can find, I already described how you can do that in my slides, and I think in one of the previous videos, if I can remember correctly. So now if we take a look, we now have two NuGet packages. We have the SQL Server NuGet packages, which we need for adding SQL Server, and we have the design, Entity Framework Design NuGet package, which we need, for instance, to create the migrations. I'm sure by now you should be familiar with migrations. So these two NuGet packages, remember them, they are important. Additionally, we will add two NuGet packages, which we only need now because we are not yet in ASP.NET. We are in a console app, and if we want to add reading of the connection string from app settings JSON, we need to add another NuGet package. It's called configuration, and you can also add Microsoft up front, and then you will see Microsoft.extensions.configuration, and in our case we are going to use a JSON app settings file. So this is the third NuGet package loosely related to Entity Framework. You don't absolutely need it. You could also type in the connection string in your C# code, but you should not do that. Always put your connection string in app settings file. So take this NuGet package. Please remember, I mentioned that in a previous video. Please remember that you do not have to add this NuGet package once we work with ASP.NET, and we will start doing that in a week or two. So this is just for now, just for building command line executables. And the second thing is, we would like to take a look at the SQL statements that are generated by Entity Framework. And for that, we need to go for logging, and we would like to print logs on the console. So we can look for logging console, and that will give us Microsoft extensions, logging console. And with that, we are done with all the different NuGet packages. Now we have installed all dependencies that we need to build a console app working with Entity Framework. Here you see the summary. These 4 NuGet packages, you need to add them in order to follow along. If I was too fast for you, just pause the video here and make sure you add these NuGet packages and remember them. Maybe you write them down, maybe you add them to your cheat sheet, because you will definitely need them in one of the upcoming exams. Good. I assume that you have now added the necessary NuGet packages, so we can start with our code. And in the first step, we would like to focus on building the data model. We would like to build the data model including relations, okay? The data model consists of regular classes. And remember what I showed you? We would like to build a shop for used Lego bricks. So one of the first things that we would like to do is we would like to create a class brick. This will represent any kind of used Lego brick that we want to sell. Just a quick recap, if we do a property with the name ID, we will get a primary key, an auto value primary key automatically. We don't have to specify anything else. Just because it is called ID, it is the primary key for the brick table. It will become the primary key for the brick table inside of our database. The second thing that I would like to add is a color. But what data type would be good for storing colors? Well, I would like to try one which we haven't tried yet in any data model that we created before. I would like to add an enumeration. You probably know enumerations, let's call them color. You probably know enumerations from C#, let's say black, and white and red and yellow and orange and maybe green, and you can add more colors if you want. The point that I would like to make here is that you can really use enumerations just like any other data type too. So you can build a property of type color and say this is the brick color in this case, and you can also make it optional if you want. In the database later on, this will become a number, an integer number, and it will reflect the integer number behind the enum value in C#. So black will be 0, white will be 1, red will be 2, and so on and so on. This is how enumerations are stored by Entity Framework inside of the database. Well, let's add a regular property, just a string with a title. And maybe make it a max length of 250, something like this. And we can also assign it a string.empty, a default value, or as long as we haven't added any value here, the title will be empty. That's fine. Good. If you can remember my class diagram at the beginning, I told you that a brick can have tags, and a tag can have multiple bricks assigned to it. So the next thing that we are going to build is a tag. So let's add a class tag here. And the class tag has, just like the brick, an ID and a title. So we can copy ID and title. Nothing special here. But now comes the important part, our first relation. And we are immediately going all in, because now we have a really interesting relation here, because a single brick can have multiple tags and one tag can be used in multiple bricks. So what do we have? We have a many-to-many relationship. Many tags can be assigned to a brick. A tag can be assigned to many bricks. Before Entity Framework 5.0, we would have had to create a separate table, a separate class. Let's call it brick tag or something like this. But with the newest version of Visual Studio, this is no longer necessary. It's really, really simple to add this many-to-many relationship. All we have to do is we have to add a property of type, something like iCollection, or if you want to keep it simple, just add a list of tag, a list of tags, and on the other side, in the tag area, we are doing exactly the same, but in the other direction. So we say list of brick and call it bricks, and that's it. If you follow this naming scheme, if you have on the one side a list of the other side, and here a list of the other side, let me draw some arrows here. This is the many-to-many relation in one direction, okay? And this is the many-to-many relation in the other direction. So we have a many-to-many relation because of the list of something. In our class, we focus on the basics of Entity Framework, but believe me, it is possible to manually configure all these relations to a very great extent. But we will not cover the details. We don't want to distract ourselves from looking at exceptions. We want to define the simple rules in order to understand the most important principles of Entity Framework. If you need more elaborate scenarios, Google is your friend. Just use Google. Entity Framework is very widely used, so you will definitely find material that show you how you can configure details. For instance, if you want to customize the name of the tables and things like that. I will not go into details here. So remember that many-to-many relationship is really simple to assign. Good. First thing, done. We will later on, once we created the database, take a look at the relational database and check out what the results of this many-to-many relationship will be inside of the database. You have to be patient for the moment and trust me that this is the correct way of doing it. The next topic that let's wait for a second. If you didn't follow along, pause the video here. Take your Visual Studio, type in this code. Let me show you this code. I will put it here. Wait for a second. I will wait for you. Pause the video and come back once you entered all this code and once you have the many-to-many relationship between brick and tag done. Good. I assume you entered the code and the code compiles. Everything is good. So we can move on to the next topic. And the next topic is inheritance. Inheritance means that we have a specialization. In my simple demo application, I will have two very specific brick types. We are going to use a base plate. You know the Lego, the big plates here? This is a base plate. So if we would like to do inheritance, we can just use regular C# inheritance. Class, base plate, and this inherits from brick. And then we can add additional properties which only apply to base plates, not to other bricks. So let's add a property of type int with length, and let's add another property of type int with width. It's as simple as that. Just add an inherited class and Entity Framework will care for the rest. By default, Entity Framework will put the base class, brick, and the derived classes, base plate, into a single table. This is called table per hierarchy because an entire inheritance hierarchy is stored in a single database table. And I will show you later on how this looks in more details. For now, for the C# part, this is all we have to do. In order to make our database structure a little bit more interesting, we will add another derived class here. Let's call it minifig head brick. You know these nice little minifigures from Lego? Yeah, it's something like this. This is the head of a minifigure. And in this case, we will do, as I told you at the beginning of this session, we will add a Boolean property indicating whether the minifig head has two faces printed on it. So does it have two faces, dual-sided, or just single-sided? So is dual-sided is the property here. So now we have our base class, brick. We have the base plate, which is a derived class, and the minifig head, which is also a derived class from brick. Nice. So we have covered another important aspect of creating a more advanced data model for Entity Framework. The point is, you don't have to do anything special. Just use C# inheritance and Entity Framework will magically, you know my term, Harry Potter programming, a little bit of fairy dust. It will just throw a little bit of fairy dust and it will store everything correctly in the relational database. Although relational databases don't know about inheritance, so they have to do some magic there, and we will definitely take a look. So please stop the video and enter this code if you haven't done already. We need the base plate and the minifig head. Good, welcome back. We have now a many-to-many relationship and we have two derived classes from our base class brick. The next thing that we can do is we can add brick availability and vendors. Let's continue with the vendors. Class vendor. This will be somebody who would like to sell some Lego bricks in our store. As always, we have an integer ID. I don't need to mention anything else. You already know what ID means. Now the vendor also has a vendor name, property, string, vendor name, and let's do it with a max length of, let's say, also 250. Looks good. Now, one vendor can sell multiple bricks, brick types if you want. But the brick, the availability or the offer is something that has additional properties. It's not like tags and bricks where we only have a relationship. A brick has tags and a tag is assigned to multiple bricks. But in this case, a brick is offered by multiple vendors, and this fact that the vendor offers a brick needs additional properties like the price that the vendor would like to have for this brick, the number of bricks that he has available. Such properties are important for this many-to-many relation. So we are creating manually another class, let's call it brick availability, something like this, and this represents the relationship between brick and vendor with added properties. So let's model that one. Again, we have our ID. We already know that. And now we have two relations. A brick is offered by a vendor. So we have to add a property of type vendor, and let's call this property vendor. This is not a list, but it's a single reference to the vendor doing the offer. It is important for us that we do not just have the C# reference, but we also want to have the foreign key value that comes back or is generated inside of the database. So we will add another property of type int, and we will call it vendor ID. So this vendor ID here is the foreign key value from the database, which leads to this C# reference, which is really relating to the vendor that we see up here. So these two things, they belong together. The ID is just the numeric foreign key, and the vendor here is the C# relation to the other object, to the other class. So in general, in this course, when we want to keep things simple, if you have a many-to-one relationship or one-to-many relationship, you always add a second property of type int to the one side of the relation in order to get the primary key, the foreign key representing the relation. We can also go the other way, because we might also ask the question, or we might want to be able to ask the questions, which bricks does a certain vendor offer? And for that, we need to be able to navigate from a single vendor to all his offers, to brick availabilities. So we will add to the vendor class a property, but this time it's not a single brick availability object, but it's a list of brick availability, because here we are at the n side of the relation. A single vendor can offer multiple bricks. Because of this, we need a list. Let's call it availability. Something like availability. Okay, let's call it this way. So they belong together. This is the n part of the relation. This is the one part of the relation. If you model it like that, Entity Framework will care for the rest. We can also add a default value here if we just want to have an empty list, as long as we haven't read the data from the database, or if we just mute up a vendor. With this, we get an empty list where we can immediately start adding availability records if we want. We will take a look at that later on. Good. Now we have the brick availability and the vendor. Of course, a brick offer needs a brick. Yeah, we are now able to generate the second relationship from brick availability to vendor. Just to make sure that I don't lose you, remember what our goal is. Here on the left hand, Here on the left hand side, we have the vendor. Here on the right hand side, here we have the brick. I'm sorry, I'm not able to draw very beautifully with my mouse. And between these two, we have a many-to-many relationship, but we want to represent this many-to-many relationship with a table, a class in our case, in the middle. And we call this one brick, I'm not good in drawing with the mouse, brick availability. I think you get the idea. This brick availability relates to a brick and a vendor. Okay, so one brick availability has a certain brick and has a certain vendor. This one, the vendor, is already done. We have done that one. The brick is still missing. We need to do that one. But we can model it exactly like we did for the vendor. So we can say public, brick, brick, and public, int, brick, ID, get, set. Now we have the second relation for our brick availability class. Well, last but not least, we need additional properties. Available amount and property decimal price euro. And as you maybe remember, we can add a data annotation here telling the system that we would like to have the type name decimal 8,2. That gives us a number which has a total max length of 8 digits, and 2 of them are the precision after the comma. So I think that looks pretty good. We now have a nice data model with the brick availability, with the vendor, with the tags. Oh, I understand that I need to add one last thing here, because on the brick side I cannot yet ask the question what bricks, what availability do we have for this brick. So we here also need to represent the n side of the relationship here to brick availability. We have the one side of the relation, but we haven't modeled the n side of the relation here. So we will have to add another property, list of brick availability, and again call it availability. That is good, and I think now we have a nice model. We can also visualize this thing with the class diagram exactly like I showed you at the beginning of this lesson, but I will not repeat that because it is not strongly related to Entity Framework. So I am happy with that one. Let me unfold the code here, vendor, and let me quickly recap the most important things. First, enumerations. Just use them. Nothing special. Entity Framework can handle them. Next thing, inheritance. Just use C# inheritance like shown here. There is one little thing missing that we need to do in the data context that I will show you later on, but in general, just use C# inheritance. Entity Framework can work with that. Next thing that we discussed here, many-to-many relationships. If you have something like that, put a list on both sides of the relationship, and Entity Framework Core 5.0 is perfectly capable of creating the intermediate table, the relationship table for you. You don't need to do anything more, it just works. If you have a more complex relationship, then model the relationship table or class manually. For instance, in our case, a vendor offers many bricks, and we have additional properties like the available amount and the price in euro, and for that we create our own relationship table which breaks up the many-to-many relationship into a one-to-many and a many-to-one relationship. So you can see it here. A vendor has many bricks available, and in a single brick availability, we have a relationship to a single vendor. So on the one side, add the reference and the foreign key property. On the n side, add the list. If you follow these simple rules, everything is fine. Let me quickly check that. Oh, I forgot here the new. This is the last thing I would like to add, and we can do that here. That's optional. You don't absolutely need to do that, but it's somewhat handy. You cannot forget to new up these lists when you want to insert new data. So I made it a habit of myself that I create these lists up here. Good. We are done. Make sure that you have entered all this code. If necessary, rewind the video, take a look at it, rewatch it, and when you're done, come back. We are going to create the database next, fill it with data, and query it. Come back when you're done. Nice, good, welcome back. We are going to continue. Let's fold up the classes here. By the way, there is a nice trick that Visual Studio understands and knows. Most of you will most likely know it, but I will add it here just to make sure that everybody knows how this is done. You can add so-called regions. And here at the end, I can say end region. And the beautiful thing here is that I can just fold up the entire region, and this makes my code a little bit more easier to maintain or get an easier overview. Okay, so if you didn't know that, it's pretty simple. Just add hash region. By the way, this works in other programming languages too. For instance, in JavaScript or TypeScript and Visual Studio Code, you can do exactly the same. You can do a comment in this case with hash region. Just look for code regions in the programming language of your choice. It's very likely that it has such a feature too. C# can very well handle that. Good. Our next topic is the creation of the data context. Of course, I do not want to enter all the necessary glue code and things that we discussed already. We are lucky because I offered you this cheat sheet. I mentioned this cheat sheet. It's part of your course material. And the nice thing here is that you can just copy out a basic data context from the cheat sheet. And I will do that. I will copy it here into my code and maybe change it slightly. I don't want to call it blogging context, but I would like to call it brick context. We will have to add some using. It's not a problem because we already added our NuGet packages. We recapped that at the beginning of the video. Just add this one and the DB set. We now have to add a bunch of DB sets for all our tables. So we have the brick with the bricks. And then we can copy this thing a bunch of times. We will have the vendor, which will become vendors. We have, what is the next thing that we have? The brick availability. And let's call this brick availabilities. And then we have the tags. And this will be the tags. And I think that's pretty much it. Oh, it's not called tags. It's just called tag. Okay, good. Now we have our DB sets. That looks good. Okay. Oh, I forgot something. I need to. Oh, I forgot the publics here. I'm very sorry. I'm very sorry. I forgot this one. Therefore, it complains that the visibility they do not match. Oh, I can make it simpler. I can just remove the public here. And then I don't have to add all the publics up here. Just make sure if you add public here and you reference another class, make sure that the class is also public, or in our case, just remove the public everywhere. We are just in a single file just to keep things simple and to have a good overview about all the code. In practice, of course, you will structure your code into files and class libraries, and then it makes sense to carefully choose between private and protected and internal and all these things. We discussed that already. Good. With that, we have all the modals here. Now comes something special, which has to do with the many-to-many relationship and, with the inheritance. Can remember the inheritance? We had the brick, and we have the base plate, and we have the minifig head. And they are derived from our base class up here. We would have to add a separate DB set for our base plates, for the minifig heads, and all the different derived classes if we want Entity Framework to store our inheritance in the database. But in my case, I don't want to do that, because I would like to show you another important feature of Entity Framework. This is new. This has to do with inheritance, but it's also important in other contexts. We can say override, please do that, and there is a very important method which is called onModal creating. This onModal creating method gets a so-called modal builder, and this modal builder can be used to configure your data model to a very large extent. Essentially, what you can do with this onModal creating, you could encode so-called Fluent API, that's the name of the API, it's just a name. You can use the Fluent API of the modal builder to add a maximum length to a string property. So it's a kind of alternative to these annotations here. So whatever you can do with these annotations, you can do it here with the modal builder too. But I don't want to distract you with too many options. So we will definitely stick to these annotations, to these attributes to define the properties of our data model. I will not go into the details of doing that here in the onModal creating, but unfortunately for doing inheritance in a data model, we have to add one line of code to the onModal creating function in order to force Entity Framework to understand that we need to store the derived tables too. And the code is pretty simple. You just say modal builder dot entity, and this time we say base plate, that's the derived class, and then we can say has base type brick, and that's all we need to do. We need to tell Entity Framework that we would like to store the derived class base plate just like we store the base class, which is called brick. Okay? Let's do exactly the same for our second derived class, which is called minifig head, and it's also derived from brick. Nice, that's it. Nothing special, pretty simple. Just add 2 lines of code to your onModal creating and your derived classes will be stored by Entity Framework. Good, nicely done. Please add this code, add the database context, and be back when you have entered this code. Good, welcome back. The last thing that we need to copy from our cheat sheet is the context factory. So let's copy the context factory. I mentioned it already, but I will repeat it here just to make sure that you remember it. We do not need to create such a context factory once we reach ASP.NET Core, but now we are just in a console app, so it is necessary to create such a factory class. Good. Let's add the using, and let's simply change here the blogging to bricks. Let's replace all the things here. Let's add the missing using statement here. Oh, we don't need the question mark here. And with that, we are pretty much done. We have now our data factory, data context factory. We have our data context, we have our data model. So we are ready to try everything and we are ready to create the database. The last thing that we have to do is we have to add the app settings JSON, and I have prepared this app settings JSON. Let's add it. It's also in your cheat sheet. Last thing, please follow along. Add a JSON file here. JSON file, and call it app settings JSON. And as we did before, it's also part of the cheat sheet. Just add the connection string, and this one will depend on your laptop, on your environment. Maybe you want to use localDB like I do, then you can just use this connection string as I show it to you here. But maybe you use SQL Server on a different server, or maybe use a SQL Server in a Docker container. The connection string depends on your specific setting. Remember, I am on the Discord server and on Teams available. So if you still have problems connecting to your local database, either check your homeworks that you already did, or check the lessons that we did last week and the week before, or come to Discord or Teams, show me your problem, and I'm more than happy to help you overcome your problems. Good. Nice. Store it. And with that, we try to build everything. We're good. Please make sure that your code compiles. The next step will be creating the migration and creating the database. Make sure that your code is fine. Come back as soon as your code compiles without errors, without warnings, and then we will continue. Hi students, welcome back. Now we have reached the first level of today's lesson. So we have done the modal, we have done the data context, we have done the data context factory. So we can try to create the migrations. For that, I ask you to open the solution or the project in the file explorer and open a command shell like this, because now we can add the migrations. .NET EF migrations add, let's call it just initial. Let's see whether everything works as expected. Oh, I did a mistake. Let's take a look. The configuration file app settings JSON was not found. Yes, I did. I did something wrong. Please go to properties and make sure that you copy the settings file to the output directory. Let me quickly run that again and redo that. Good. Now you can remember from our first videos with Entity Framework, we now have the migrations. I will not go into the details, they are just there. We create them, and whenever you change something in your model and you do not want to recreate the database from scratch, you always have to add migrations. Once we have migrations, we can apply the migrations to the database. Let me quickly choose another database name, Bricks lesson. Let's call it Bricks lesson. This one is good. And then go here, and this time we say .NET EF database update. This database update will take our migrations that we have here in our C# code, you see it here, and apply them to our database, which is referenced by our app settings JSON file. Let's do that. .NET EF database update, it will generate the SQL statements, apply the migrations. This looks pretty good. Let's go into Azure Data Studio. I've already tried some things here, so ignore what I have open here. Let's refresh. And here you see Bricks lessons, and we see our tables. Now let's take a look at some of the things that were generated from our model. Let's put this one here on the right-hand side, and let's put this one here on the left-hand side. That's good. And let's make this a little bit smaller and go into our program CS, because then I can show you a bunch of things in the generated model. First, let's take a look at the enumeration here. The enumeration is part of the bricks. And if we take a look at the columns, then you will see, just as I told you, the color enum in C# will become an integer value, and this integer value is the same value that we have in C# behind the enum. You probably know that a C# enum in the background is nothing special, it's just a number with a name, and stored in the database is just the number. The next thing that I would like to show you here to point your attention to is the definition or the data structure with which Entity Framework stores inheritance. Please remember, here we have the brick class and we have two derived classes which use brick as their base class. So we have a relationship from these two classes up here. And here you see how this is done. We only have a single table for the entire inheritance for the entire inheritance relationship. This is called table per hierarchy because we store the entire inheritance hierarchy in a single table. And Entity Framework will understand for each entry in this single table whether it's a brick or a base plate or a minifig head by taking a look at this special column here. The discriminator column. The discriminator column is of type text, and it contains the name of the class that the object is of. So if we have an object of type baseplate, the discriminated column will contain the word baseplate. That's essentially how Entity Framework stores the data. An interesting thing is how it stores the properties. You see these properties, the properties of the derived tables. And you see that here. It will add all the properties of all the tables of the entire inheritance hierarchy. If we have a base plate in a row in the database, the is dual-sided will simply be null because a base plate does not have the property is dual-sided. If we store a minifig head in a row in the database, length and width will be null because there is no length and width for a minifig head. Understand the principle? Nullable columns are added for all the properties of all the derived classes, and they are null depending on the type of the row in the database. Once we have added some data to the database, I can show that based on demo data, but for now we just take a look at the database schema. Let's continue. The next thing that we had in our data model is something interesting because we had the many-to-many relationship between tag and brick. A brick can have multiple tags. A tag can be assigned to multiple bricks. Here we have the tag, as you can see it here. So we have our bricks, they are here. Our tags, they are here, and just like magic, Entity Framework came up with a relationship table connecting these two things. Brick tag is the name of the relationship table. We have never created a class which is called brick tag. The creation of this table was done by Entity Framework automatically, and this connection table is, as you can see it here, just consisting of two columns. The first one is the relation to the tag, and the second one is the relation, oops, wrong direction, is the relation to the brick up here. So this is how Entity Framework stores a many-to-many relationship automatically inside a database. As I told you, this is brand new stuff. This is only available since .NET Core 5.0, so the version that we are using here. So be lucky. You are lucky. In earlier versions of Entity Framework, you would have to create this table on your own by creating another class in your data model. Good. Let's take a look at the relations, at the simple relations, the one-to-many relationships. For instance, if we take a look here from the brick availabilities to the vendors, it's pretty simple. On the brick availability side, we have the vendor ID, you see it here, as the foreign key to the vendor table. And this is exactly that, that property. So this vendor ID here is transported, it's stored in the vendor ID here. And when the data is loaded from the database, the C# relation to the vendor class, which we can see up here, is filled automatically by Entity Framework. So in the database, we obviously don't have a C# object relation. We only have the foreign key. And from the foreign key, C# will understand that it has to create a C# relation between two objects. Okay, so here are the two foreign key columns from brick availabilities to bricks and tags. Nice. So this is the structure that has been created from our data model with .NET EF migrations add and .NET EF database update. Good. Please try to recap that on your own machine. Try to add the migrations, try to apply the migrations to the database, open the database in SQL Server Management Studio or Azure Data Studio and check the generated database structure, check whether everything is just like I've shown you. Make sure that you didn't forget any kind of relationships, because we will need that in the next part of this lesson when we add data using these relationships and when we query data using these relationships. So, fix your code, make sure it runs, and be back as soon as you're done. Welcome back. We have now reached the second level of today's lesson, the data context, and applying the data context to the database. Maybe we will also put a region around this one and region, and call this second region data context. You see, I can now fold this region, and I can focus. Oh, I did something wrong. The enum, this one, of course, should already also be inside of the modal. Let's make our code beautiful. I like beautiful code. So now we can focus on our business logic, and we have simply moved everything else away so we can really focus on the code which is now important for us. Good. Let's start by creating the database context using the factory. That one is simple. Var factory equals to new brick context factory. And then we can create the context using var context equals to factory.create db context. Is good. Now we have a data context, and now we can start adding data. Let's put all the related code for adding data into a helper function. Let's make it async task add data and add the necessary using, and call this one await add data. This is what we want to do, and here inside of this add data method we are going to play around with our data. Let's first do something very, very simple. We would like to add a bunch of vendors. Vendors are really nothing special. Let's add, let's say 2 vendors, okay? Let's remember those vendors. So let's say vendor, I don't know, Brick King and Held der Steine, a famous YouTuber regularly showing interesting Lego buildings. Maybe you know him. And then let's create objects and add them to the database. This is now Entity Framework code, context.addRange, so we can add multiple things at the same time. Let's create a new array because we would like to add multiple things in one go. Let's store the Brick King, new vendor. We can shorten that one, because the system, oh no, we cannot, because I have to specify it here. And the vendor name should be Brick King. That is a very simple line, and we will duplicate it, Held der Steine, and call it here Held der Steine. Now we have 2 records added to this array, and with the add range async we simply do 2 inserts in the database. That's nothing special. We have done that multiple times over the course of the last weeks. There is nothing new here. Just one small thing that I would like to point out. You see this, adding the comma at the last line of the array? That's a habit that you could consider for yourself, because if you add the comma here, next time when you want to add another row, you can immediately start typing here. You do not need to go back in the previous line and add the comma and so on. So C# is perfectly fine if you add a trailing comma here, just to be ready for the next row to be added maybe later on to your code. Of course, it's fine like this too, but I wanted to point out this nice little feature of C# because it makes your life somewhat easier. Let's store this data to the database. Await context.save changes async, nothing special. We could already start this, but I don't want to. It's pretty simple, nothing special here. We also want to add some tags. So we have to exercise. So let's add some tags. Tag, let's say a rare tag. We have a Lego Ninjago tag, and we have a Lego Minecraft tag, for instance. And then I will just copy the range async from up here, and also copy the save changes from down there. And I can now add the rare tag, rare equals new tag, and the title should be rare. And let's copy, bang, 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 these 3 times, because we want to have Ninjago, and we want to have Minecraft, and we want to have Ninjago, and we want to have Minecraft. Good. Again, nothing special, just adding a bunch of data. Maybe I didn't mention that already before, but maybe this is new for some of you. You can declare a variable here, and then you can assign and work with the new object at the same time. So here I am assigning the new tag instance to a local variable, and additionally, because I'm here inside of this new statement, I'm also adding this object to the array. I do not need to write that in 2 different lines. That has nothing to do with Entity Framework, don't get me wrong. I'm just pointing out some interesting aspects of C#, because maybe these aspects make you a better programmer, a better C# programmer. Good. Now, let's go into areas where we haven't been before. Now let's add a more complex object graph in one go to our database. And for that, we are going to add a base plate brick, okay? Await context.add async new base plate. So far so good, nothing special here. Let's add a title. Maybe this is a base plate 16 by 16 with blue water pattern or something like this, something that we can use for Minecraft, because we want to make this colored green. We also have green, that's fine. And now comes the important part. Let me write the code, new, and now we can add our tags from up here. This base plate should be rare, and it should be from the Minecraft series of Lego. Now comes the important part here. Please stay with me and follow closely. I am creating a base plate object. And in this base plate object, I have multiple tags because we have a many-to-many relationship between bricks and tags, and I can add these tags here. And without me writing this in multiple lines like I would have in SQL, I would have to create a single insert for the bricks table, a single insert for the tags table, a single insert for the relationship table between bricks and tags. I don't need to do that in C#. In Entity Framework, I can build a graph of object. I can add multiple related objects, even for many-to-many relationships in a single go. And Entity Framework will split that up automatically into multiple insert statements for multiple tables. That's the beautiful thing here. That's the important thing that makes Entity Framework, when it comes to relations and many-to-many and one-to-many relationships, so useful. So let's continue with that, because we have a second thing where we can apply this. We can say the length should be 16 and the width of our base plate should be 16. And now we want to make this thing available too. So we can say availability, and remember, that's again a one-to-many relationship. So we can create a new list of brick availability. This availability is a list of brick availability, so we can add, just like here with the tags, multiple availabilities in a single add async. Let's do that. New, The vendor should be who? The brick king. Okay, vendor is the brick king. The available amount should be 5 and the price euro should be, I don't know, 6.6, 6.5. Let's say 6.5. You see the important thing here? We are working with C# object relationships. We don't need to care about foreign keys, which you already know from your database lessons. We don't need to add again a separate insert statement in the separate table. We can add the base plate with all its availabilities in a single go. I hope you understand what I mean. When we run this code, in a minute, you will immediately see how that works out. So maybe let's add another availability record here. Let's say this is Held der Steine, and Held der Steine has, I don't know, 10 pieces of that available, and he is a little bit cheaper. Let's make it like this. So now we will try this. Oh, save changes async, of course. Now we will try this code and check what is stored in the database for this single add async method. This is the core where I wanted to go to in this lesson. I wanted to demonstrate to you how powerful adding object graphs to the database is with Entity Framework, using many-to-many relationships and one-to-many relationships. Okay, let's make sure, yes, we call add data here. Let's compile this guy and let's see whether I did any syntax errors. If I was too fast, let me quickly show you the entire code here. This is my add data method. Make sure you entered all this code. I will wait here, pause the video, make sure you entered everything and everything compiles correctly before we run our app and take a look at the results in the database. Good, you're back, so your code should work now, and I will run it. Maybe I will do another console write line. Let's say I'm done, something like this, just to make sure that we know that everything is okay. And run it, run it, run it, done. Looks good. No errors, no exceptions. Let's take a look at the database. Let's put again this one here and put the query window here. Let's get rid of the connections and connect to my bricks lesson here and say select star from bricks. That is the first table I would like to take a look at. Now we will see a few interesting things here. First, we have one record. That is correct because we only added one record. The discriminator table, the discriminator property here is base plate. Why? Because we have used the derived table, the derived type base plate here. So we now have an instance of the base plate class here. It also means that the property of the other derived class, which was called minifigure head, is null because a base plate does not have the property is dual-sided. See that? That was done automatically by Entity Framework. Now, what about these relationships? Did Entity Framework correctly add the tags and the connection between our base plate and the tags? Let's check it. Let's say select star from tags and run both queries. You see, we have the base plate and we have the tags. And now let's do the last query from brick tag. This was the relationship table which was automatically generated for the many-to-many relationship. So let's run this guy. And here comes the magic. Here comes our Harry Potter programming. We never created this table. We never explicitly added anything to a list of something like this. We just assigned the tags to our base plate. And Entity Framework did the heavy lifting and connected our brick ID 1 with two tags, with the tags rare and Minecraft, which is exactly what I specified here on the C# area. So you see, with a single line of code, I added a bunch of rows to the database, which makes our lives much easier. The same is true for availability. So if I take a look here at brick availabilities, let's do this one and select this one, we see that our availabilities here work perfectly fine. We have the available amount, we have the price euro, everything's fine. It was added in a single go. So this is what I wanted to demonstrate when it comes to adding data. Do not write C# code where you add all these things, the base plate and every single tag and everything single availability in separate C# statements. You can give entire object graphs to Entity Framework, and Entity Framework will figure out how to generate the appropriate insert statements. So by now, you should see and understand that Entity Framework, having an object relational mapper, is a really useful thing. A really useful thing when it comes to working with databases. Good. With that, we have completed our add data exercise, and we can move on to the next and final exercise of this lesson, to querying data with relations. Maybe it's a good time for now to fetch a coffee or get something to drink or make a short break, and be back in a few minutes, and then we will cover the last thing, querying related data. Welcome back. We will now focus on querying data. For that, we will add another helper method, async task query data, and here we will add some link queries. We can comment out the add data helper method because we already did the experiment, we already added some data. If you want, you can add some additional data rows, but for our exercise, it's not necessary. So let's add an await query data. Good. And here we can try our link queries. Let's start with a query that references brick availabilities. Just to make sure that you can follow along really nicely, I will open the data model again and show you graphically the data model that we have built. Here you see the brick availability. Brick availability has a vendor who is offering the bricks and has a relation to the brick which is offered. And for this brick, we have multiple tags, and each availability has a price and an available amount. This is, just to refresh your memory, this is what we have built so far. And this is what I would like to query. I would like to query some availability data, something like this. Await context dot brick availabilities. This is my entry point. I would like to query some availability points. Some brick availabilities. Of course, I could add some where clauses. Of course, I can add some order by. Of course, I can add some group by, but this is not the point here. This is not what I want to do. I would like to immediately return all brick availabilities. It would be done like that, but now comes the important part. When I have relationships, in my case, a brick availability is related to a vendor who is offering the brick and the brick that is offered. If I want to load not just the availability but also these connected objects, I can use the include clause here. And I can say brick availability, please load brick availability, please load the related brick. I can say include, another include, brick availability, please also include the vendor. And if I do something like this, Entity Framework will generate an SQL query that will do a join between these three tables. Are you interested in the join? Well, I am. So I will turn on logging here in the brick context factory so we can take a look at the generated SQL statements together. Let's quickly add a little bit of output for each. Var item in availability data. And then we can say just write line. What do? We say brick item.brick.title available at item.vendor name for item.price euro. Something like this Should be nice console, of course. Console write line. Now let's take a look at the output and let's take a look at the generated query. Let's run this guy. Oh, I have a mistake. Where do I have a mistake? Let me see here. Oh, I didn't add the using statement. I'm very sorry. I added this line, but I didn't add the using statement. This is an error that is very easily fixed. So let's give it another try. And let's see. Okay, brick base plate is available at Brick King for 650 and at Held der Steine for 590. So the result looks good. Let's take a look at the SQL statement. Let's zoom in here a little bit. And as you can see, Entity Framework does exactly what I promised you. By using the include clause, it's generating a single query with two joins from brick availabilities to the related tables, bricks and vendors. This is exactly what I wanted to have. So please remember, .include is the best and simplest way of enforcing a join of multiple tables. And it's important for us to do that, because if I would remove that one, if I would forget the include, then I would get the brick availabilities, but I would not get the vendor data. So if I run this guy without the include, I will get an exception. My application will crash because, as you can see it here, vendor is null. However, now if we hover over item, you will see that the vendor ID, the foreign key, is there. So the foreign key is always loaded by Entity Framework. But the relationship, the entire vendor object, is not filled. It's empty. But we want to print the vendor name. Therefore, we absolutely have to add the include statement up here. Do you understand? Include enforces a join. The join fills your related objects and lists and so on and so on. Good. Let's add this row again. Let's maybe do a console write line to get an empty line and do another experiment. This time I would like to get a list of all bricks with the vendors of this brick and with the tags of the brick. Let's start with the tags. Var brick with vendors and tags await context.bricks. Let's start, as I said, with the tags. That one is pretty simple. I can just say include brick goes to brick.tags. Now it looks the same as above, but it is very much different because up here I used a many-to-one relationship. One brick availability has exactly one vendor and exactly one brick, but this time it's different. We have multiple bricks and each brick can have multiple tags. So in this case, I'm really filling a collection, not just a single object reference. Let's see how Entity Framework does that, and let's see whether we can work with this data. Let's add some output again. Var item in brick with vendors and tags, something like this. And say write, console write. Let's add brick item.title, something like this. And then we can say if item.tags.any. So if the item has any tags, then I would like to print all the tags of the item, of the brick. So let's say console write here and say, let's put it in brackets, something like this, and use the very convenient string.join method where we can just say separate the tags with a comma and display the item.tags, and from the tag use, I will do that with a select statement, tag.tags. title because we want to concatenate the titles. And that should give us a list of bricks and in brackets their tags if they have one. Let's run this guy and let's take a look at the output and analyze this statement again. Now, as you can see it down here, the output works perfectly fine. It says rare and Minecraft, which is the correct list of tags for our base plate 16 by 16. That is good. But now comes the interesting thing here. What we see is the select statement up here is far from being trivial. It is starting at the bricks table and it joins the brick tag table, which assigns tags to bricks, and it's joining the tag table. So what I want to demonstrate here, you don't need to take a look at this query in details. If you want, you can. So if you are curious, copy the select statement and run it in Azure Data Studio and try to understand it. But the point is, you don't need to know this complex SQL query. Just by saying include all the tags of the brick, you get everything that you need, and C# will fill the necessary lists and relations just as you need them. And then you can just as I did it here, just print them. Okay? Please note that if you want to do a where clause, for instance, something like this, if you want to say, I don't know, dot where brick, exactly brick and brick dot tags dot any with tag goes to tag title equals to Minecraft, something like this. In this case, you do not explicitly need to do the include clause. If you have the relation directly here in your link query, you don't need to explicitly add the include clause. Then it's done automatically. But if you have, let's say it here, no specific reference in the link query up here, and you would nevertheless like to access the related data later on outside of the link query, then you have to tell Entity Framework to add the related table to the SQL query that it generates. That's the important thing here, okay? This is why we need to add the include clause here. Now, what about the vendors? The vendors are more difficult. Let me show you why. Let's bring the class library, the class diagram up here. If we take a look at the bricks and we want to navigate to the vendors, we have to go over brick availability. So it's a two-step hop. We need to load for each brick the brick availability and the vendor information. And we want to load everything in one go, okay? So we need to add another .include statement here. But the complex thing here is now that we need to add a two-stop hop. And for that, we can use a very special string-based syntax. We can say, go to, from the brick to I will mistype. So I will use the name of here, brick.availability, plus the dot sign and plus name of. Then we need to add the vendor, so we are at the availability, brick availability dot vendor. This is what we want to have. So we just say availability dot vendor, and this will make sure that all bricks are loaded. For all bricks, all availability data is loaded, and for every availability record, all the vendors are loaded. And with that, we can add a little bit of output. If item availability.any, if a brick is available, we can add another console write, where we, for instance, print something like, I don't know, let's say is available at, and do the same string dot join with the comma, something like this. And in this case, we are using item dot availability dot select, and we would like to go for availability vendor name. This is what we would like to have. See? So in this case, I am now doing a multi-stop include, and that will give us the bricks, all the availabilities, and of each availability, the related vendor. And then we can access all this data inside of our processing. Okay? Let's give it a try. Let's take a look. Okay, let's take a look whether the output is correct. And I can see it immediately here. We have the brick data, we have the tag data, and here we also have the availability, the vendor data. Very, very nice. But the point is, what I would like to make here, and please take a look at the query here. See that query? That is really not trivial what's going on behind the scenes here. We have multiple joins, multiple left joins with subqueries and things like that. Do you understand the value that you get from Entity Framework? You can load object graphs with a single query using the include clause. Very, very simple. You do not need to build these complex SQL queries with complex subqueries and joins and so on. All you need to do is you need to tell the system that you would like to load related data together with your base objects. And then you can easily access all this data because everything is in memory from the very beginning. Okay? Now, there is a last special case that I would like to cover at the end. And this, you will, by the way, you will definitely need the include clause in some of the upcoming exams. So you need to understand includes. You will need this include with many relationships. So not just single relations, but also these many relations. It's very likely that you need to write something like this. The last one that I will now add to close up this session, this is something that I will probably not ask you in an exam. So it's again a nice little add-on that I would like to show you to close this session in an interesting way. For this, I am going to copy this query up here. Let's call it bricks, simple bricks. And I will just say to array async without any include statements. Now let's also copy, I don't need to copy it, it's so fast. I can say var item in simple bricks. And now I would like to do exactly what I have done up here. But now I have a big problem. If I do it like that, and if I run this statement like this, it will work. At least it should work if I didn't do anything wrong. And you see, we have the brick, we have the, sorry, I did something wrong. Oh yeah, of course, I tricked myself. Can you remember last week's lesson? What I told you about the change tracker and things like that? Well, I have loaded these items up here, and if I load them again, of course the tag data is still there. So I tricked myself into something, so let me comment that one. So we have just this query down here. Now I can run it again. Sorry for my misunderstanding here. So let me run this query again. And the important thing is that now here we get the data about the brick, but what we miss here is the tags. But our base plate has tags. We know that. So this one is not entered. This line is not entered here. Why? Well, because we don't have an include clause here. We could, of course, just like here, add the include clause, but I want to show you, I told you that, a different way of doing that. Because what you can do in Entity Framework, you can ask Entity Framework to explicitly load the related information for a specific item a little bit later. So after the original link query was already done, I can ask Entity Framework, hey, please, Entity Framework, I made up my mind. I didn't ask you to include the tags at the very beginning when I asked you for the bricks, but now I made up my mind, I need the tags. So what I can do is I can say await context.entry item, and then I can say collection item tags load async. This line here will explicitly load the tags of this specific item if I need it. Okay, so if I run this guy, we will now, hopefully, if I don't do something wrong, yeah, here it is. It will load our tags just as we want it. Okay, so again, if you take a look at the SQL query, you will see that this query is not very trivial, but this is why we have Entity Framework. It works perfectly well. Nice. With that, we are at the end of today's lesson. So let's quickly recap what we did, and then we can close for today. And in Discord and Teams, I will give you the homework where you can practice all these things. For those of you who are not inside of our class, but you are following this course maybe online on YouTube, always check our GitHub repository. Here is the GitHub repository. You can take a look here in the exercises folder, and if you want to do the exercises too, you can find them down here. For instance, here you see the exercises of the last few weeks for Entity Framework. Okay, so good. So let's quickly recap what we did. Today we created a way more complex model. We have talked about enums, about derived classes, about many-to-many relationships, about one-to-many relationships, things like that. We have taken a look at the generated SQL structures in Azure Data Studio, and we found out that Entity Framework generates tables on the fly, generates foreign key relations on the fly. It does a lot of magic for us. The next thing that we took a look at is how to add object graphs, where we add not a single row to the database, but multiple rows by just adding a single C# object. And last but not least, we closed by taking a look at queries where we access related data. You learned about the include clause, with which you can force Entity Framework to eager load related data, to load related data together with the base entity that you would like to access. I showed you simple include clauses, I showed you include clauses for one-to-many relationships, and I showed you include clauses for complex navigation patterns through connection tables, like here in our case the availability table, which connects bricks and vendors. And with that, we are done. Thank you for your attention. Please, if you have any questions, if you have any problems, come back to the Discord server or to Teams. I am more than happy to support you, to help you over any problems, or to describe some concepts again, so to make very sure that you understood all the contents of this lesson. Thank you for attending the class. See you later on Discord or on Teams. Goodbye for now.